Hey guys, welcome to another episode of Friendly Academy. Now in this episode, we are going to learn how to access a DynamoDB privately through an VPC endpoint, VPC gateway endpoint, and as well as how to use resource-based policies that was recently announced by the time of this recording to block any public access to this DynamoDB altogether. So that's the main intention of this video, and let's get started. So when we are developing applications, it's important that we keep our private resources private. And if we have a DynamoDB table like this one, and we don't want anyone else like Lambda functions or whatever the EC2 machines or any resources in the internet to access our DynamoDB, we should block it. But if we only wanted to keep the access to our virtual private network or VPC in our AWS account, then we should only enable that one. But until recently, DynamoDB didn't support resource-based policies, so that the permission to access DynamoDB has to be controlled through identity-based policies. Alright, before we proceed, let me explain what identity-based policies and what resource-based policies. Now, as the name implies, resource-based policies are applied to the resource itself. So in this case, we apply this policy to the resource DynamoDB, and then we'll define who can access this DynamoDB table. So essentially, when we define an identity-based policies, we can set different principles. For example, a particular IAM user can only access this DynamoDB table. Or another principle could be an IAM role. So this IAM role can access this DynamoDB table. Or it could also be a different AWS account. Let's say you have a list of AWS account and you only want two AWS account to access this particular resource. So then you can add those AWS account IDs. So such a way you can define IAM resource policies so that you can define who can actually access this DynamoDB table. Now because of that, one of the distinction between resource-based policies and identity-based policies is that resource-based policies includes the principal ID, because we have to define who can access this particular DynamoDB table. Now on the other hand, IAM policies are applied to resources, and it says what can this resource do. Now in this case, we have a Lambda function. So if we define an IAM policy, identity-based policy to this particular Lambda function, it will say, okay, you have these permissions. For example, I can say you can access this particular DynamoDB table, but only get item query. But when we deploy this whole setup to AWS and try to access this DynamoDB, AWS IAM service is evaluating all the permissions that is coming from identity-based policies as well as resource-based policies to determine whether this particular resource, in this case Lambda, can access DynamoDB. Now, if you go to AWS documentation, the policy evaluation logic, so this is the page, policy evaluation logic, and if you scroll down to the section evaluating identity-based policies with resource-based policies, you can see it's taking the union of permissions. Now what this essentially means is a resource-based policy has certain permissions defined for different principles. Now identity-based policy has an additional permission. Now when we are evaluating it, it will consider the union of allowed permission. Unless of course, if either of these policies, resource-based policies or identity-based policies, have an deny explicit permission, then that will take precedence. So if resource-based policy says, okay, you can't access this particular actions, let's say DynamoDB get item action, whereas the Lambda identity-based policies allow the Lambda to do get item, DynamoDB get item permission, in that case we have a explicit deny through the resource-based policies. So that will take precedence and that request will be rejected. So let's look at this in the demo. But another one I want to quickly share with you is this particular page. So this is about AWS services that work with IAM. Now here in this table, it includes all the AWS services, and whether they are supporting resource-based policies or other different type of policies. Now, if you look at services like DynamoDB, Amazon DynamoDB, as you can see, the resource-based policies are enabled for DynamoDB. Now, this is the recent update from AWS. But however, if you look at services like step function, the step function service, the resource-based policies are not supported. So only the caller, let's say Lambda function is invoking the step function, can have identity-based policies, but you can't have any resource policies to the step function that we are going to access. Now, if you look at the other services like API Gateway also provides resource-based policies, and SQS. So SQS is also allowing resource-based policies. Now, you should use this table as a reference whether a particular resource support resource-based policies. Okay, so without any further ado, let's get started with the demo today. So in this particular demo, I have a DynamoDB table already created, by the way, and also I have created all these resources, but I'll show you like all the configuration in each resource because I wanted to keep this video a little short. And I will also provide you the infrastructure as code using serverless framework and CloudFormation so that you can use that to deploy this set of resources. Okay, so what we are going to do, we have a DynamoDB table, and in this DynamoDB table, we'll define a resource-based policy, and that resource-based policy only allow accessing this DynamoDB table through a VPC endpoint. Because of that, if there's another resource on internet trying to access this DynamoDB, those calls will be rejected. So in order to demo that, I will have another Lambda function, public Lambda function that is outside this VPC trying to access it, and we will see if this request is rejected. And also I will have another Lambda function inside the VPC, inside a private network, trying to access this DynamoDB through a VPC gateway endpoint. Now here we are going to use gateway endpoint because DynamoDB and S3 supports VPC gateway endpoints. The other services like step functions, API gateway, we have to use interface endpoints. And by the way, if you want to learn how to use VPC interface endpoint, you can check our previous video where we try to invoke a step function through an interface endpoint. But in today's video, we are going to use a gateway endpoint, and gateway endpoint, you don't have to pay anything really. It's free and scalable service. Okay, so let's get started. Okay, so I log into AWS console and I'm in DynamoDB. Now in DynamoDB, I have a table, and this table has one item. So that is nothing but the PK is 100, first name, the last name. That's the only entry I have there. And I also have defined a permission here. You see now there's a new tab called permission-new. This is particularly for defining our resource-based policy. So I've added a resource-based policy. So let's go and explore that policy. I click edit. Let me zoom in just a little bit. So this is a resource-based policy attached to DynamoDB resource. And you can see the resource here. So I'm attaching to my DynamoDB table. My resource policy has one statement, and that is a deny statement. So this is a deny statement, and what is it denying? It's denying adding item to DynamoDB. You see this put item and getting an item, querying items, update items, delete items, batch item get, batch write item, like all these basic operations that we usually do with DynamoDB. So we are going to deny it, and I've defined a condition, and what that condition is, if the request is not made through a VPC endpoint. So I've defined a VPC endpoint. So this is that VPC gateway endpoint for my DynamoDB. So if that request is not made through this DynamoDB VPC endpoint, then we are going to deny all these actions. So I'm using this string not equals. So when we make a call to DynamoDB through a DynamoDB VPC endpoint, so this is the DynamoDB VPC endpoint. So it carries this VPC endpoint ID, and that is the endpoint ID we will check. We are checking if any DynamoDB request that contains these actions does not have that VPC endpoint ID, then deny it. So this is that policy statement. So in this case, if you are making a DynamoDB call through the VPC gateway endpoint, let's say a get item or query, put item, batch get, or whatever those actions that is defined in that list, we don't deny those requests from the resource policy level. We will deny it, however, if the request is made from outside that VPC endpoint, such as from a different Lambda function that is outside the VPC and trying to access it, then that request will deny, because it doesn't include the VPC endpoint ID. So that's the first part. So let's look at these two Lambda functions. So I have two Lambda functions. Now this is the first Lambda function. I call it VPC Lambda. And this VPC Lambda, as the name implies, it's in a VPC. So I have one of the VPCs. I'll quickly show you. If I go to the configuration section, and in this configuration, I'll go to VPC. So this Lambda is in this VPC, and it is attached to my private subnet, private 1 and private 2. So I defined my private subnet such a way that it doesn't have any route out to internet. So whatever the resource associated with this private subnet do not have access to internet. So how am I then accessing this DynamoDB? So that's where I'm creating a VPC endpoint. So this particular VPC endpoint, and this VPC endpoint is available in VPC service. I can go to VPC, and in this VPC section, I'll go to endpoints, and here's the endpoints that I've created. So the service name is com.Amazon AWS US West 1 DynamoDB, because I'm in the US West 1 region, and the type is gateway endpoint. Now just to show you how to create it in the AWS console, you can click create endpoint, just add test, and here AWS service, and you can type that DynamoDB, and here we go. This is the DynamoDB. Now DynamoDB, I'm using this gateway type. It also has the interface type, but I use gateway because gateway endpoints, for gateway endpoints we are not getting charged, but for interface endpoint we are getting charged for every hour. So, and I'm using gateway endpoint, scalable endpoint type, and then I'm associating that VPC. So the VPC that I associated with it, and then the private subnet. So I've associated the two private subnet where my Lambda functions are added. So my Lambdas are able to connect to this gateway endpoints. But unlike in VPC interface endpoint, for gateway endpoints, we have to add a route out to this gateway endpoint in the route table associated with this private subnet. So that can easily be done. For example, once you create this service, you will have a record like this, the endpoint record, and you can click on this endpoint, and then you can go to action, and there's this option manage route table. So you just have to select the route table associated with the subnets. In my case, I have two subnets, private 1 and private 2, and they have two different route tables. So these are the two route table, and then I'll click modify route. So this will automatically add that record to the route table. For example, I'll go to this one of the route table. I'll click on this link that will take me to this route table, and if I select it and go to routes, so I have this particular entry added. Now this is the prefix list of DynamoDB. This includes all the IPs associated with DynamoDB service, and it is targeting to the VPC endpoint, DynamoDB VPC endpoint, the one that we just created. If you go to the prefix list, you will see all the IP addresses. I click it again here. There you go. So these are the IP addresses that AWS DynamoDB service lives, and any request to these IPs is pointed to the gateway endpoint. So from AWS SDK, when we make that DynamoDB call, it will go through this VPC gateway endpoint. Now, in addition to that, I also have a public Lambda, which is this one. So I call it NonVPC Lambda, and this is not associated with any VPC. So if I go to the configuration and go to the VPC section, there's no any VPC configuration. This is a public Lambda. But however, the code is the same. So I'll go to the code and quickly show you the code. So this is the serverless YAML I'll share with you. VPC Lambda and the non-VPC Lambda. And if I go to the Lambda handler code, I have two handlers, handler.vpc Lambda and handler.non-VPC Lambda. So in my handler code, so this is the code in VPC Lambda. It is just doing a DynamoDB get item query. So this is the table name. I take the table name and then I particularly add this pk equal 100 because I have only one record. That's the record I want to fetch. And then I get it and then I console log it. If there's any errors, I cache that error and then console log it. Similarly, it's the same function for non-VPC as well. So it's the same code. Back to my serverless YAML file. Now in this serverless YAML file, I have this IAM role statement. So I have one IAM role, and that is associated with both of these Lambda functions, VPC Lambda as well as non-VPC Lambda. So what this identity-based policy says is, it says each Lambda is allowed to do DynamoDB get action for the DynamoDB table. So I'm getting the DynamoDB table ARN. So both of these Lambdas are allowed to do DynamoDB get item. So this is provided. So this permission is provided to their identity-based policy. But however, in our resource-based policy, we say you can do get item, put item, those operations only if the request is originated from a VPC endpoint. Now, I have already deployed these resources. So if we go to the non-VPC Lambda, which is not in a VPC, I go to test and then try to test it and see if we get that result. So this is the data that it returns to us. I get status scores 500 and look at this error message. It says the IAM role that is associated with that Lambda, which is the same IAM role, is not authorized to perform DynamoDB get item on the resource. That the resource is our DynamoDB table, because there's an explicit deny in the resource-based policy. I think this message is very clear because it didn't match our resource policy, because that request is made over the internet and it didn't satisfy this condition. Because of that request was rejected and we didn't get that result. Okay, now let's go to our VPC Lambda, which is this one, VPC Lambda, and this Lambda is in the VPC. So I'm going to go ahead and test this again. I'll click test. There you go. I got 200 status code with that item pk100, first name and the last name. So this returned correctly. So notice how the public Lambda, although it had IAM permission to get item, it was not able to fetch that item. Now let's do a small change, right? Because as we already discussed, if we don't explicitly deny from the resource policy and our IAM identity-based policy has a permission, then it will still access it. So here I'm going to remove this get item, DynamoDB get item, or I'll comment it out from my DynamoDB resource policy. So this is my resource policy, and I will leave the rest as it is. So in this case, both the Lambdas has get item. What do you guys think will happen? So let's test this. So I'll go ahead and I'll do a deployment. All right, it is deployed. So let's go to our resource policy and then do a little refresh here. I'll refresh this page. I should see this get item is gone. Yeah, so there's no longer that get item in the deny list. So now if I use my NonVPC Lambda, which is trying to access it over the internet, will it be able to access it? So let me test it. Yes, now it is able to access it. And our VPC Lambda, let's see if it is still able to access this one. There you go. So it is also able to access it. So the point I want to highlight here is when AWS IAM evaluate the resource and identity based policies, it's taking the union unless of course there's no any explicit deny defined in either of these policies. Okay, so it's important when you are using resource policies, make sure you add the correct list of actions that you want to deny from public, and also make sure the principal, like right now I've defined the principal as star, but you can define the principal like only for that IAM role associated with that Lambda functions, or you can define it constrained to a particular AWS account or IAM user, so on and so forth. So you have to be careful defining this principle as well, because these resource-based policies are, I would say, more permissive, because these apply to the resource. So if you enable like star, and then for example if you do allow here, that means this policy, and I remove this condition as well. Now it's a allow statement. So this means from anywhere in the internet we are able to access this DynamoDB. It doesn't even need any permission. So this is like very dangerous. And in fact, if you try to save it, AWS will throw you an error like resource-based policy grants unbound access in one or more element. Please revise the policy to ensure least privilege form of access. Yeah, so this is what I want to show you in this video, guys. How can we use both resource policy and identity-based policies to convert a DynamoDB to a private DynamoDB. Yeah, thanks for watching, guys. This is what I want to show you today, and I'll see you in another video.